Hi everyone, before going directly into the part 2, I want to say that this video is a little bit different from every video out there where they just explain how to do questions. Here I'm also going to go into model responses and we're going to go over the reasons why people get full score or a partial credit or no credit at all. So let's just go ahead and start. We're going to do it in two parts, a short response. It's going to be part 2 and part 3. Here we're going to do questions from 25 to 32, I think. And we're also going to try to go over every single response set. All right, so having said that, let's just go ahead and start right away. So first we are going to solve the question because, well, how else we are going to compare to what we let's say what we have to what should be there, and we're going to grade the answer too. This is the first time I'm seeing these questions. I haven't solved them yet. This is a new Regents. It's June 2025, so literally doing these questions as I see them. So that's the whole point, to see and do the questions and to see what would we get doing it. So let's just go ahead and start it. All right. So a survey was taken to determine whether students prefer to watch videos or listen to music. Of 100 surveyed, 44 seniors, 65 students who prefer to watch videos, 42 juniors. Use the information to complete the frequency table below. All right, so not a lot of mathematical knowledge needed here. It's just basically basic logic here. So let's just go ahead and start with the easiest part here, is to having a total of totals, which is 100 students serving. So this is going to be where total and total intersect. So it's going to be 100 over here. All right, so now we have that. Now they say that 44 were seniors. All right, so seniors total, right? Seniors total, 44. And right away, automatically, I know how many juniors there were, 56. Why? Well, because they have to add up. Like juniors plus seniors have to be total of the totals. All right, so now we're going to just keep filling up the table. All right, so of the 65 students who preferred to watch the videos, 42 were juniors. All right, so of 65 students who prefer to watch videos, so we know that 65 people prefer to watch videos. All right, videos total 65. And now out of those people, 42 were juniors. So 42 who watched videos are juniors. And now we also know that right away that seniors who watch the videos are 65 minus 42, because again, this plus this must add up to that. So 65 minus 42 is going to be 23. And basically to fill up the rest, you don't need any more information. So it's going to be, well, it has to add up again. So it's going to be 35. Here it has to add up 23 plus whatever is here has to add up to 44. So it's going to be 21, because 23 plus 21 is 44. Just subtract, it's pretty logical here. And 14. All right. So even though, let's say, I don't think that you do that much in the Algebra 1 class, I bet that you haven't really been spending time doing it. But this is something that you shouldn't be skipping. This is something that you should just look at and be like, okay, I think I can figure it out, and figure it out. All right. All right. So do we need anything else? No. They just say use the information to complete the frequency table. That's all. All right, that's going to be, should be 2 out of 2. All right, so there is nothing here to check. So this is the first 2 out of 2 score. You see that? It says score 2. So this is 2 out of 2, and everything just neatly placed. What else? Nothing. Just 2. Just a score 2. All right. This is score 1. Why? The student wrote 21 correctly in the table, but no further correct work shown. Like did not like calculate correctly. This does. I mean, I think this was supposed to be over here. Was supposed to be a 5. Other than that, I think everything is correct. 21, what is it, 16, 23. Ah, there's supposed to be 14 here. Okay, yeah. Well, a couple of calculation errors, I think. That's why you get 1. Generally correct, just pay attention to the numbers though. Okay, this is 1. What is that? Just calculations here and there, just subtract it. 55 plus 35 does not give you 100 though. And it says 65. Come on. Just don't be lazy and like, paying attention. Just get, this is something that you need to get 2 out of 2 for, because if you need to, like, you need to collect as many, like, let's say, I wouldn't say free, but as many points as you can. All right, so moving on from there, just incorrect work. All right, 0. What is that? Just random numbers. Really? Random? 165. Why 100 was here? It says out of 100 students were surveyed, 44 were seniors, not like 100 were serious. Seniors. Seniors are serious. All right, so, and that's it. Really? That is it. Moving on. Question number 26. First, we have to solve it. So solving a classic inequality is just solving a classic inequality. This is pretty much it. No mysteries here. 10 minus 5y greater than negative 11y minus 8. Maybe I want to subtract 10 first to get rid of it here. So it's going to be negative 5y. Don't forget, negative 11y minus 18. All right, now plus 11y plus 11y is going to be 6y greater than, this goes away, and negative 18. Divide by 6 in the end, and we get y is greater than negative 3. That's literally it. Like not there's much to discuss. All right, so and this is exactly what happened here, I think. Yeah, pretty much. That was score 2. Another score 2 where usually we put a variable first, right? But I guess over here they counted it like this, not because it's not technically a mistake, so they have to. It's technically correct. Y then bigger than negative 3, so it's negative 3 less than y. All right, this. Switch the sign. Do you see that? You're not supposed to switch the sign if your division is by a positive number. Let me make this a little bit thicker. Yes. If what you're dividing by is not negative, you don't have to switch the sign. So that's why you're probably gonna get a 1. Yep. What is that? Negative 11 and then plus. So that's exactly what I said in the beginning when I was doing it. You see, a lot of students, and literally a lot, forget that when you get rid of this, the minus doesn't go away. It belongs to the 5. It belongs to the 5, so it has to stay. It has to be here. And if you forget that, you're going to make a mistake, so don't forget that. So, what I usually suggest is just make a box out of, that's for the beginners, but still, make a box out of every term. This way you will never forget, including the sign in front. This way you will never forget that even if you get rid of the 10, the negative will go with the 5. All right? Next. Where, what, how? We don't know. 18, 6y. And in the end, y equals. You see that? Equal sign. I think it's a 0. Which is, yeah. No way this can be correct. All right, that looks neat, but what's wrong with it? Okay, so started with plus 8 gives you 18. That's legit. Now plus 5y plus 5y. Okay. So look, you can use a calculator for these calculations. You do have a calculator for these calculations. On the test, you have a graphing calculator where you can, I'm not going to use a graphing calculator because I don't need to graph anything or any of that sort. But you have negative 11 plus 5. Negative 11 plus 5 is negative 6, not negative 16. Just use a calculator. Just double check. You know, no one's rushing you. And that's why, but really, that doesn't even deserve a 1? That's tough. I think that deserves a 1 because technically just one mistake. You divide by 16, yeah, you get. Ooh, that's harsh. I hope you don't have that teacher who gives you a 0 for that. This is a clear 1. This is. You think that this and this has anything in common? No way. This person clearly knew, just made one mistake. All right, next question. So you see, a lot depends on your who's checking your work. So, all right. Again, no mystery algebra type of work. All right, so it's going to be a distributive property, double distributive property. So what you have to do is you have to distribute this onto both of the inner terms of the second parenthesis. So 5x times negative 2x is going to be negative 10x squared. 5x times 7 is going to be positive 35x. Negative 3, and don't forget, this is a negative 3. Negative 3 times negative 2x is positive 6x. Negative 3 times 7 is going to be negative 21. Do we have like terms? Of course we do. It's in the middle here. So it's going to be negative 10x squared. Positive 35 plus 6 is going to be positive 41x minus 21. And this is a standard form. It doesn't go any further. This is it. That's the correct answer. Grab those points. Grab those points. Look at this. Neat, correct. Not even the arcs. Box method, which I personally hate, officially. Whoever teaches kids this method should ask themselves questions like why? Why do you need to do this and overcomplicate things? You don't need to. Nor you need to know that method. Just learn this because that's what you use all the time. All right, so 1 out of 2. So what was the problem here? Okay, forgetting, you see that minus 6x? That came from not knowing that it's negative 3 times negative 2, which is supposed to be plus. That's it, just one. Boom, boom. Arcs, 10, 10, 10, 10, 10. Squared, though. Squared, has to be squared. When you multiply 10x squared plus... why did I write not that? Distractions, guys, distractions. All right, so this is, okay, so let's say that this does not apply to that at all. It's just multiplication of two terms. Negative times negative, in your, like, basically in your mind, it has to go, okay, it's going to be positive. All right, and now 10 times 2 is going to be 20. And now x times x is x to the second power. And that's how you get your answers, right? Standard form, highest exponents in the front. Yes, but where? Where is the highest exponents? None. It's clear 0. Here. Just wrote everything in a row. This could be legit if that would be a plus in the middle between two parentheses. But don't forget, if there is nothing in front of, like in between the parentheses, if there is nothing, that means that you need to multiply. If you have a plus It's a different story. You just open the parentheses and combine like terms. What this person did actually correctly in terms of if that would be a plus in between, but not this time, buddy. Not this time. All right. Next question. Next question is going to be about the first and the fourth terms in arithmetic sequence are given below. Determine the eighth term. All right. So there are a couple of ways to do it. First of all, you see the words arithmetic sequence, you should be like, I think there is something about arithmetic sequence is in the formula sheet, like on the last page of the test. So we're gonna go there in a second. Which we need to use. Although this question is solvable without the formula. Why? Because they're asking only for eighth term. How many terms do we have? Like first, second, third, fourth, right? So what is it? Like a couple of more terms there. So we can just find it this way. Because it says determine. Determine means just like find by whatever means necessary. That's how I see it. But if we want to be politically correct, we need to go there. What if we're going to get a teacher who gives you 0 points for almost the correct answer? You know, so we go all the way down and we look for it. Arithmetic sequence. You see that? Copy this into your answer. Maybe you'll get a 1 just for that. Who knows? A1 plus D. Okay, so I cannot really copy it, so I'm just gonna do it by memory. Like I don't remember, which I do not all the time. Equals to A1 plus D times N minus 1. Just one more time for confirmation. Yes. And let's go back and solve it. You know, when you have a formula and you have a question and you're about to plug in some stuff into those variables, into those letters, right? It's like a kitchen table. You need to prepare your things. So, and you need to know what's what. So A1 is what's called first term. Do I know the first term? Yes, I do. It's right over here. Okay, so that's ready for me. AN is basically what I'm looking for, like A8. Okay. Now D. What is D? D is a common difference. Common difference. Like, what do I have to add or subtract to jump from first to the second, from second to third, from third to the fourth, and so on? So, do I know the common difference? No. I don't know yet. Maybe I can figure it out, probably, but I don't know it. So it's probably, oh my God, it's probably going to be negative 20 plus, let's just keep it as D for now, and then N. N is the term that I'm looking for. Since I'm looking for 8th term, the 8 is going to go for the N. All right, so the only thing that I'm missing is that D. If I'll find that D, I will find the answer. Let's find D. I don't know why did I do that just now, but I'm not gonna edit it out for sure. Okay. How are we gonna find that common difference? So there's a jump from negative 20 to something, then from that something to another something, and from that to negative 2. Now, the jump is going to be adding something, right? Because, well, it went from negative 20 to negative 2. So the worst case scenario, just try all the numbers. By all the numbers, I mean just try adding 2. Like, let's say, oh, negative 18, negative 16, no. Try adding 4, blah, 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 no. How do I find it officially? What's the way? What's the algebraic way, Roman? You want to ask me, what is that? And the way is subtracting the term that you have minus the other term, the first term. Subtracting like the whole thing. the negative 20. So I have to do negative 2 minus negative 20, which is plus 20. Minus minus turns into a plus, which is 18. Now I have to answer the question, how many times do I jump technically? 1, 2, 3. That's what I have to divide that number by. How many jumps I have? It is going to be 6. So the common difference is going to be 6. Can we check that? Yeah. Negative 20 plus 6, negative 14. Negative 14 plus 6, negative 8. Negative 8 plus 6, negative 2. Checks out. Now, all I have to do is to plug in that 6 over here. So 8 minus 1, 7. 7 times 6, 42. Negative 20 plus 42 is going to be, use a calculator if you don't know, it's going to be 22. And that's the answer. Now, you could have just added 6. Keep adding 6, like 5th term, 6th term, 7th term, 8th term, and you'll get there. And I think that's legit. And we'll see whether it's legit or not. Maybe it's not. Maybe it is. Who knows? Let's see. Jumps 6. I can see that. All right. You know what? Let's use red. Formula. Good. And just plugged everything in like we did here, here, and 8th term goes here. That's it. I like those step 1, step 2, step 3. Like the teacher is not going to understand like if that is step 1, 2, and 3. But, you know, nice to see that. So determine the common difference 6 and just started adding it. Look, boom, boom, plus 6, plus 6, plus 6, plus 6, plus 6, plus 6, plus 6. Why did you go until 10? If you needed 8th, couldn't stop on time, you know, like, oh, I'm going to keep going. But correct, and it's a legit way. It literally says determine, and that's a legit way of finding it. All right, number 28. Let's see. So first term, yes, f of 1 though. Okay. Plus 6, plus 6. Fifth term is 4. Oh. So the problem of this guy was like just writing probably like terms, numbers, and see that fourth term is negative 2. Fourth term is negative 2. So the fifth term will be in negative 4. I don't know. Literally would give you 0. The guy probably got 1 point just for putting the formula and finding the common difference. But this just confusing. All right. A. The number is plus 9. So if negative 2, the fourth term, the one, what? Just kept adding a till I got to the 8th term. 34. Incorrect. 18 divided by 2 should have divided by 3. Probably would have gotten that right. Why by 2? Nobody knows. Got 1. Okay. Plus 6, plus 6, plus 6, plus 6. That's good. Formula is good. What's wrong with it? 6 times 7, 42. Oh my God. Look how this person got it wrong. Add it before multiplying. PEMDAS. Add it before multiplying. Everything's correct. Common difference is correct. Formula, plugging in, everything's good. And just all of a sudden, instead of getting 42 and then doing negative 20 plus 42 to equal to 22, negative 98. But you correctly determined the common difference. Wait, didn't it occur for you to check? Just to check. You have negative 2. You know that this is the first term. You have common difference 6, so plus 6. Fifth term, 6th term, 7th term, eighth term, 22. This is not supposed, and negative 90 is 98. Like, it goes up, and you are all the way down. Score 1, but so close, yet so far. Good preparation table, I would say. Just incorrect. What can I say? Just incorrect. I mean, just no work. That would be probably make more sense. Okay, copied the formula, tried, plugged in, almost, and then nothing, 0. All right. We got through that. You know, previous regions were so much more fun. So much more interesting answers. Just not here. All right. Write an equation in slope-intercept form. So you need to know what a slope-intercept form is, which is our favorite form, y equals mx plus b. That passes through the point -2 and 5, and it has a slope of -3. So all we need to do is, like, what are you missing? You have x coordinate, y coordinate, you have m. The only thing that you're missing is b. If you find b, you will find the answer. It's actually low-key, pretty easy if you know a little bit of linear algebra. Let's go. So it's going to go like this. 5, we're plugging in. 5 equals -3 times -2 plus b. 5 equals 6 plus b. Subtract 6, we get -1 equals to b. So the final answer will be y equals to -3x minus 1, because that's what we're missing. What was missing? Only 1. -1. That's the answer. They say use the set of x's below is optional. Well, why do we need that? We don't need that. We don't need that. We don't need to use it. It looks like a graphing question, which is not. Not at all. Let's look at the answers right away. Yeah. No work, though. But yeah. Does it say determine? Right. It says right in equation. So you wrote. And that's enough. Having those points, yeah, I guess. Yeah, using another form and figuring out b was algebraically also good. So far, nobody used my method. Surprised. -2 just did negative rise over 1, 3 over 1, and then did 4 over 1, and that's the mistake. Just went one extra square. Ooh. Yeah. Just -3 though. -3. And almost got it right, but not. Oh, it's 0. You know, this is this is great, where the point is not on the line, which they say that the point passes through, like the line passes through the point, clearly not here. Like, then you should ask yourself, like, maybe I'm doing something wrong there. No? Ooh, that's what I love the most. Look at that. First of all, a couple of lines put together. Second of all, not that bad, right? What is it? -2, 5, -2, 5. That's here. 3 over 1, 3 over 1, 3. No, I mean, down 3 times 1. Yeah, here's your b. If only you would have studied that in y equals mx plus b, b is the y-intercept, and then you would have gotten that right. That's it. 30. I'm thinking, is this video like already long enough for you to watch, or should I keep going? Maybe I'm gonna go for one more, and then I'm gonna do another part. Just don't want to make it way too long. All right, factor an expression completely. We have to factor. Can I teach you that? Like, oh, here is a specific way for you to do that. No, just studying is the answer here. Right? So first we're going to factor x out. Why? This guy has 3, this guy has 1 of them, so let's take 1 from both. We're going to have x squared minus 36. Now I'm going to recognize that this is a difference of two perfect squares, which is x squared minus 6 squared. That breaks into two parentheses, x plus 6 and x minus 6. This comes from the formula a squared minus b squared. If you want to learn more about it, it's called difference of two perfect, oh my god, squares. How's my cursive writing via using the mouse? All right, let's go over the answers. All right, just correct. The first question, or the first answer, right, is just correct, neat, nothing more. Second, the box method, which I'm never going to understand, but somehow correct. Third answer, it says factor, it doesn't say solve. So but this is the correct factoring. So are you going to get points off for solving it, even though it's partially correct? Would you give this person points off for doing extra? That's the whole debate that we have to have. Yes, well, in this case, they did. The student factored correctly, but attempted to solve the factored expression as an equation. So the question is, do we subtract points for doing extra or not? Even though we did the part that is being asked correctly. Maybe, maybe not. Would I? Would I? I would not take points off. I would probably come up to that student and say, hey, you didn't have to solve it. Your factoring was enough. Pay attention next time. Yeah, I would not. 4. You have 36. You're going to do 4. That's just random. 18, no. 36 is 6 squared, not 18 squared. So, and solved it too, so nah. Almost. If you would have put the x outside and just make this into a 1x, then yes, and also solved it. You know, people keep solving it when they say factor. Guys, factor doesn't mean solve. Factor means factor. All right. So I'm going to stop at question number 30. I'm going to do another video because we need to go over 4-point questions. There's much more to go over. 4-point answer, 3-point answer, 2, 1, and 0-point answers. But I hope this video helps. It shows you how people answer questions, what you need to pay attention to. And throughout the year, if you want to make sure that you're going to get a good grade on your Regents exam, I'm going to run once a week an online class for Algebra 1, for Geometry, for Trigonometry. And if you're just going to come in and do this once a week for like 1 hour, I guarantee you're going to do well on the Regents. There's no way you won't, because we're gonna learn how to use the calculator properly, this, and that. At least what you're going to get is 80. Yeah, you can reach me out at the email you'll find somewhere on YouTube probably, or just comment and I'll reach out to you. If you want to see when the new video is going to come up, just subscribe. I don't post that much, so it's not going to take a lot of your YouTube recommendation space. So having said that, that will be it. I'll see you everyone next time.